In this video, we're going to take a look at identities for the hyperbolic functions. So to begin with here, what I'm going to do is I'm going to give the first hyperbolic function that you need to be familiar with. So this is going to be cosh squared x. So cosh squared x minus sine squared x identical to 1. Okay. Now, as an A-level first math student, you need to be able to prove these hyperbolic identities. So how do we prove these identities? Well, we use the exponential definition for sine x and cosh x. Okay, so in that case then, this would be cosh x squared minus sine x squared. Okay, so cosh x, that would be e to the x plus e to the minus x all over 2. Okay, so that's squared. We can square this here. We know minus sine x all squared, so minus. We're going to have e to the x minus e to the minus x all over 2, and again this is squared. Okay, so this is my left hand side here, so what I want to do is simplify this here and show that that's 1. Okay, so in this case here, because we're squaring a fraction like this, this is just equivalent to squaring the numerator and then dividing that by the square of the denominator. Okay, if I square the numerator here, this is just simply the expansion of 2 brackets, so it's going to be e to the x plus e to the minus x multiplied by e to the x plus e to the minus x. Okay, but in this case here, just expand using FOIL or any method that you're familiar with. So e to the x multiplied by e to the x, that would give me e to the 2x. I get e to the 2x. When I multiply now e to the x and e to the minus x, that just gives me 1, because this is the same as 1 over e to the x. So I've got 1 there. And when I multiply these two together here, e to the minus x by e to the x, again, I get 1. So I've got 1 plus 1 giving me 2. And then finally, e to the minus x multiplied by e to the minus x, that gives me e to the minus 2x. Okay, so plus e to the minus 2x there. That's my numerator. We now divide this here by 2 squared, which is 4. That's divided by 4. That's my first bracket. And what I'll do, I'll just put it in brackets there just to make it clear that it corresponds to this one. We now minus this expression here squared. So again, I just need to expand the numerator here using double brackets. In this case here, this would be e to the x minus e to the minus x. So just be very careful here with the signs. It's really easy to make a little mistake. Again, e to the x minus e to the minus x. Okay. But expanding this here, I'll just do this straight away over here. I'm going to get e to the 2x again. Rather than positive 2 this time, we get minus 2. And then again, we get e to the minus 2x. So plus e to the minus 2x there. Okay. And this is all over 2 squared, which is 4. So again, put this in a bracket here, just to show that this corresponds to my second bracket squared here. So from here now, we need to perform the subtraction. And because they're both over a denominator of 4, a common denominator, we can just perform the subtraction here. So e to the 2x over 4 minus e to the 2x over 4, they'll just cancel. I've then got 2 over 4 minus 2 over 4. So we'll come back to that in a moment. Let's just cancel this final bit here. I've got e to the minus 2x over 4 minus e to the minus 2x over 4. Sorry, so let me just get that right. So e to the minus 2x over 4 minus e to the minus 2x over 4. So there we go. So they cancel as well. And what that leaves me with then is 2 over 4 minus 2 over 4. Okay. So put that in a bracket there just to make it clear. So if we minus this negative number here, and in that case then it's just the same as adding them together. So what I've got then is 2 over 4 plus 2 over 4, giving me 4 over 4 there. And obviously 4 over 4 is equal to 1. And that's exactly what we wanted to get, right? So in that case then it's equal to the right hand side, and our proof is complete. Okay? And that's how we'd prove an identity like that. So in a hyperbolic identity, we'd prove using the exponential definition. So make sure you are familiar with that concept. Like to see, that's just a very basic example, but that's the kind of thing that you're going to be required to do. Okay? Well, there we have it. So that's our first hyperbolic identity. So cosh squared x minus sine squared x is equal to 1. And what I'm going to do is I'm just going to clear the screen, and what we'll do is we'll list the hyperbolic identities that we need. So we've just got the first one there, so that was cosh squared x minus sine squared x is equal to 1. So that's our first hyperbolic identity there. Okay, so let's just bullet that. What else do we have here? Well, we have another hyperbolic identity that you should be familiar with. We actually established this in the introductory video for hyperbolic functions, and that is tan x is equal to sine x over cosh x. Okay, and you might be looking at that and thinking that looks pretty familiar or pretty similar to the A-level maths, A-level maths trig identities, and you'd be correct in thinking that. So tan x is equal to sine x over cos x. Okay, so notice here, rather than it being sine x, it's sine x, rather than it being cos x, it's cosh x. And this is important because what this is here is an example of Osborn's rule. Now, Osborn's rule is really important because rather than having to kind of memorize all the different hyperbolic trig identities, Osborn's rule kind of helps us with that. Because if we know a trig identity from the ones that we study here in A-level maths, then we can usually find the corresponding hyperbolic trig identity by using Osborn's rule. So what does Osborn's rule state then? Well, it says that we replace sine with shine. So replace sine by shine. Let's just do that here. And we replace cos or cosine with cosh. Replace cos with cosh. Okay. So for example then, if we have sine 2x, so sine 2x here, without actually knowing what this hyperbolic identity is here, we can just use the A-level maths identity. So from A-level maths, sine 2x, that would be 2 sine x cos x. Okay, so 2 sine x cos x. In this case then, my hyperbolic identity here will be 2 sine x cosh x. So 2 sine x cosh x. Now before I state any more hyperbolic identities here, there is a caveat to Osborn's rule, and that is that if we have a product of two sine terms, then my result won't be sine squared. So for example, let me just show this in action. Oh, sorry, not sine squared, but let me just write the actual result down here. So if I have, say, sine A multiplied by sine B, then the product here we have to replace with a negative. Okay, so this won't be sine A, sine B. Okay, so like we said here, we replace sine with sine. But if we have a product of sine terms like this, then we need a negative. So that's going to be minus sine A, sine B. Okay, that negative is important, that we do need that. Okay, obviously you have to be very careful then for anything that involves a product of sine terms. So generally speaking, if you have an identity that involves tan squared x, because we express tan squared x as sine squared x over cos squared x, then clearly you need to be very careful here because we have that product of sine terms there in the numerator. Okay, so do take that on board. It can come up quite a bit, and it is important that you don't fall into that mistake there. Okay, that's sine 2x, 2 sine x cosh x. So that's my other hyperbolic identity there. That is given in the formula book though. We've got another hyperbolic identity here. So if we have cosh 2x, so cosh 2x, again, we have to be slightly careful here. So let's just go back to the identity for cos 2x from A-level maths. So cos 2x. So cos 2x you should hopefully be familiar with, and you should know that that is given as cos squared x minus sine squared x. So cos squared x minus sine squared x. So if you're not careful here, what you might say the identity is for cosh 2x is cosh squared x minus sine squared x. But you'd be incorrect in saying that because notice here we have a product here of sine terms, sine squared. But in that case then the sign will change. So for cosh 2x, this is equal to cosh squared x. So cosh squared x plus sine squared x. Okay, so do take note there that that minus sine squared here, this product of sine terms, makes the identity become positive here for sine squared. Okay, so that covers all the identities here that we need for A-level further maths for hyperbolic identities. Like I said, if you're ever wanting to prove these results, these identities, then you need to use the exponential definition. Okay, so if you fancy a bit of practice, have a go at proving this result here using the exponential definition, so for sine 2x, and have a go for cosh 2x. Okay, but there we have it. So that brings us to the end of this video on the hyperbolic identities. In the next video, what we're going to do, we're going to take a look at solving equations involving hyperbolic functions.